It is against code to make a pigtail in the panel board. National Electrical Code Section 110.14 Copyright addresses this situation directly. To be permitted, a splice or tap must be located within an accessible enclosure where conductors are not normally exposed to physical damage. Applying this to the described scenario of a 30-amp 2-pole circuit breaker in a 480 volts panel board where a number 4 wire is being used to account for voltage drop but the breaker only accepts a number 8 wire, making a pigtail within the panel board is a code violation. The reason is that while the panel board itself is an enclosure, splices and taps made within it are typically not considered to be made in a manner that meets the requirements of 110.14 copyright without additional measures. The National Electrical Code provides comprehensive guidelines for electrical installations to ensure safety and proper functionality. It is crucial for electricians and anyone working with electrical systems to understand and adhere to these regulations. Splices and terminations are critical aspects of electrical work, and the code specifies how they should be performed to minimize the risk of electrical hazards. Now let's delve into the specifics of NEC Section 110.14 copyright and its implications for the scenario. The primary concern of this section is to ensure that splices and taps are made in a secure and accessible manner, protecting them from physical damage and environmental factors. The requirement for an accessible enclosure is particularly important, as it allows for inspection, maintenance, and future modifications without compromising the integrity of the electrical system. In the context of a panel board, the enclosure itself is designed to protect the circuit breakers and other components from external elements. However, simply making a splice or tap inside the panel board does not automatically satisfy the requirements of 110.14 copyright. The splice must be made using approved methods and materials, and it must be properly insulated and secured to prevent accidental contact or loosening. Furthermore, the enclosure must provide adequate space for the splice and any associated hardware, ensuring that it is not overcrowded or subjected to excessive stress. There are several reasons why the NEC restricts the practice of making pigtails directly at the breaker within the panel board. Firstly, space within the panel board is often limited, and creating splices can lead to overcrowding and difficulty in accessing other components. Secondly, the environment within the panel board can be subject to temperature fluctuations and potential moisture exposure, which can degrade the insulation of the splice over time. Thirdly, if the splice is not properly made or secured, it can become a point of failure, leading to arcing, overheating, or even electrical fires. Therefore, the NEC requires that splices and taps be made in a dedicated enclosure that is specifically designed for this purpose. These enclosures are typically equipped with features such as strain relief, insulation barriers, and grounding provisions to ensure the safety and reliability of the splice. One common solution for connecting a larger conductor to a breaker that only accepts a smaller conductor is to use a listed splicing block or terminal block within a separate junction box. This approach provides a secure and code-compliant way to transition between the different wire sizes. The junction box should be located adjacent to the panel board, and the conductors should be properly protected and supported as they enter and exit the enclosure. It is also important to note that the size of the junction box must be appropriate for the number and size of conductors and splices it contains. NEC Section 314.16 provides detailed requirements for calculating the minimum volume of outlet boxes, conduit bodies, and junction boxes. In addition to using a separate junction box, there are other methods that can be used to address the issue of connecting a larger conductor to a smaller breaker. For example, some manufacturers offer circuit breakers with lugs that are specifically designed to accommodate larger conductors. These breakers eliminate the need for a separate splice and provide a direct connection between the conductor and the breaker. However, it is important to ensure that the breaker is properly rated for the size of the conductor being used, and that the installation complies with all applicable code requirements. Another option is to use a listed reducing connector, which allows you to directly connect the larger conductor to the smaller breaker lug. These connectors are designed to maintain a secure and reliable connection while reducing the size of the conductor to match the breaker lug. However, it is important to select a reducing connector that is specifically listed for use with the type of conductors and breakers being used, and to follow the manufacturer's instructions for installation. Ultimately, the best approach for connecting a larger conductor to a smaller breaker will depend on the specific application and the available equipment. However, it is essential to prioritize safety and code compliance when making these decisions. Always consult with a qualified electrician or electrical engineer if you are unsure about the proper way to perform an electrical installation. Failure to comply with the NEC can result in serious consequences, including electrical fires, injuries, and property damage. To further clarify the requirements of NEC Section 110.14 copyright, it is helpful to consider some specific examples of situations that would be considered code violations. For instance, simply wrapping the larger conductor around the smaller breaker lug and taping it would not be considered an acceptable method of termination. This practice is not only unsafe but also violates the code requirements for proper splicing and termination. Similarly, using wire nuts or other unlisted splicing devices inside the panel board without providing a separate enclosure would also be a code violation. These devices are not designed to be used in open environments and may not provide adequate protection against physical damage or environmental factors. It is important to remember that the NEC is not just a set of guidelines but a legal requirement in many jurisdictions. Electrical inspectors are responsible for enforcing the code and ensuring that electrical installations are performed safely and correctly. Failure to comply with the code can result in fines, delays, and even legal action. Therefore, it is in everyone's best interest to follow the NEC and to consult with qualified professionals when necessary. In addition to the requirements of NEC Section 110.14 copyright, there are other code sections that may be relevant to the scenario described. For example, NEC Section 310.15 provides requirements for conductor ampacity, which is the maximum current that a conductor can safely carry. When using a larger conductor to account for voltage drop, it is important to ensure that the conductor is properly sized to handle the load current. In some cases, it may be necessary to upsize the conductor even further to meet the ampacity requirements. Another relevant code section is NEC Section 250, which provides requirements for grounding and bonding. Proper grounding and bonding are essential for electrical safety, as they help to prevent electrical shock and reduce the risk of electrical fires. When making splices or taps, it is important to ensure that the grounding and bonding conductors are properly connected and terminated. Furthermore, NEC Section 408 provides specific requirements for panelboards, including requirements for overcurrent protection, wiring, and grounding. These requirements are designed to ensure that panelboards are installed and maintained in a safe and reliable manner. Now, let's consider some additional factors that may influence the decision of how to connect the larger conductor to the smaller breaker. One factor is the available space within the panelboard and adjacent areas. If there is limited space, it may be more difficult to install a separate junction box. In this case, it may be necessary to explore alternative methods, such as using a breaker with larger lugs or a reducing connector. Another factor is the cost of the various options. Some methods, such as using a breaker with larger lugs, may be more expensive than others, such as using a separate junction box. However, it is important to consider the long-term costs of each option, including the cost of maintenance and repairs. A third factor is the ease of installation. Some methods may be easier to install than others, depending on the skill and experience of the installer. However, it is important to prioritize safety and code compliance over ease of installation. Finally, it is important to consider the future needs of the electrical system. If there is a possibility that the load will increase in the future, it may be wise to install a larger breaker and conductor now to avoid having to upgrade the system later. In summary, the question of whether it is against code to make a pigtail in the panelboard is a complex one that depends on the specific circumstances. However, the general rule is that splices and taps should be made in a dedicated enclosure that is specifically designed for this purpose. This requirement is intended to ensure the safety and reliability of the electrical system and to prevent electrical hazards. Always consult with a qualified electrician or electrical engineer if you are unsure about the proper way to perform an electrical installation. To provide additional context, let's discuss some common misconceptions about electrical wiring and code compliance. One common misconception is that as long as the wires are properly insulated, it is safe to make splices anywhere. This is not true. The NEC specifically requires that splices be made in accessible enclosures, regardless of whether the wires are insulated. Another common misconception is that wire nuts are a universal solution for splicing wires. While wire nuts are a convenient and widely used splicing device, they are not suitable for all applications. Wire nuts must be properly sized for the number and size of conductors being spliced, and they must be installed according to the manufacturer's instructions. Furthermore, wire nuts are not designed for use in wet or damp locations. A third common misconception is that it is always permissible to upsize conductors to account for voltage drop. While upsizing conductors is a common practice, it is important to ensure that the conductor is properly sized for the load current and that the overcurrent protection device is properly sized to protect the conductor. Failure to do so can result in overheating and potential electrical hazards. A fourth common misconception is that electrical work is a do-it-yourself project. Electrical work can be dangerous and should only be performed by qualified professionals. Attempting to perform electrical work without the proper training and experience can result in serious injuries or even death. A final common misconception is that the NEC is just a suggestion. The NEC is a legal requirement in many jurisdictions, and electrical inspectors are responsible for enforcing it. Failure to comply with the code can result in fines, delays, and even legal action. Therefore, it is essential to take the NEC seriously and to consult with qualified professionals when necessary. In addition to the specific requirements of NEC Section 110.14 copyright, it is important to be aware of the general principles of electrical safety. These principles include always working with de-energized circuits whenever possible, using appropriate personal protective equipment, and following safe work practices. Before starting any electrical work, it is essential to verify that the circuit is de-energized using a voltage tester. Even if the circuit breaker is turned off, there may still be voltage present in the circuit. Therefore, it is important to use a reliable voltage tester to confirm that the circuit is truly de-energized. When working with energized circuits, it is essential to use appropriate personal protective equipment, such as insulated gloves, safety glasses, and arc-rated clothing. These items can help to protect you from electrical shock, burns, and other injuries. It is also important to follow safe work practices such as avoiding contact with grounded surfaces, using insulated tools, and keeping a safe distance from energized equipment. Furthermore, it is important to be aware of the potential hazards associated with electrical work, such as arc flash, electrocution, and explosions. Arc flash is a dangerous phenomenon that can occur when a short circuit or other fault causes a sudden release of energy in the form of heat and light. Arc flash can cause severe burns, blindness, and even death. Electrocution is the result of electric current passing through the body. Electrocution can cause muscle spasms, cardiac arrest, and death. Explosions can occur when flammable gases or vapors are ignited by electrical sparks or arcs. Explosions can cause severe injuries and property damage. To minimize the risk of these hazards, it is essential to follow safe work practices and to use appropriate personal protective equipment. In conclusion, electrical safety is a critical aspect of electrical work. By following safe work practices and adhering to the requirements of the NEC, you can help to prevent electrical hazards and ensure the safety of yourself and others. Remember that electrical work should only be performed by qualified professionals. If you are unsure about any aspect of electrical work, it is always best to consult with a qualified electrician or electrical engineer. They can provide expert advice and ensure that the work is performed safely and correctly. The information provided here is for general educational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified professional before performing any electrical work.